Hi everybody, welcome to our virtual classroom, which is actually my kitchen and dining room. I just want to first say I hope that you had a great spring break and that you are safe and you are healthy, because we are thriving in this quarantine. Let me introduce you to our new co-teacher for the class. Come here, come here, come here. Good girl, come here, come here. Everyone, this is Lady. Lady is so excited to learn math with you. So, as we go through this virtual learning process that's new for everybody, just be like Lady and be patient, ask questions, and take a lot of naps if you need it. So we're gonna get through it, so let's get started. All right, so the last time that I saw your beautiful faces was when we had just finished arithmetic and geometric sequences. So this is very similar to those geometric sequences in the form of this exponential function. So we're kind of familiar with exponential functions. What we probably aren't very familiar with is logarithmic functions. So these are connected, just like addition and subtraction. Logs and exponents are the opposites of each other. So they're inverses of each other, which means they cancel each other out. So we would read this log as log base b of a equals x. And this exponential we would read as base b of x equals a. And these letters are fluid throughout. So this number a, whatever it may be, is the same number as this number a. So, for example, on your assignment, your first problem is log base 3 of 81 equals 4. And you are asked to rewrite this in exponential form. So in this case, b would be what number? 3, right? The little number. Our a is going to be this number here, this 81. And then x is our 4. So we're literally putting it in this form. So you know all of the letters, you just now have to write it in this form. So in exponential form, this would be your base, which was 3, to the x power, which is 4, equals a. So a was 81. And if you type that in your calculator, you would actually see that 3 to the 4th power is indeed 81. So this right here is all that I am looking for. Okay, so let's do number 2 as well, just to make sure that you got it. So we got log base 17 of 289 equals 2. So again, we know that b is the base, which is 17. A is the number that we're taking of the log, so 289, and x is 2. So if I'm writing this in exponential form, then I just need b, which is 17. I need x, which was 2, equals 289. Whoops. And then there's our exponential form. And again, you could type that in your calculator to prove that it's true, but I promise you that it is. So that is how we are writing logs as exponential form. Now, if you look at number 11 through 20, then you see that they're in exponential form. You're asked to write it in log form. So let's look at number 11. So we're just working backwards now. So number 11 is 1/9 to the 2nd power equals 1 over 81. So if I follow this, b is now 1/9. The x is now 2, and a is 1/81. So if I'm writing this in log form, then obviously I need the log, right? And my base, b, is this 1/9. So 1/9 is my little number here. And then I need a, which is what we're equal to in this case. So 1/81, excuse me, equals my x, which is the exponent in this case. So it equals 2. So here is my log form. So again, if you can identify a, b, and x, this should be very quick for you. So let's do number 12, just to, again, make sure that we got it moving backwards. So we have 625 to the 1/2 power equals 25. So again, my b is 625. My x is the exponent, 1/2. And then a is 25. So I'm going to write it once again in this log form. So log with my base b, which b is my big number in this case, so 625. And then we want a, so a is what it equals, so 25 equals x, which is my exponent, so 1/2. And there it is in log form. So you just rewrote logs as exponentials, and vice versa, you wrote exponentials as logs. So again, just make sure that you can identify b, a, and x. If you can do that, you should be able to go back and forth between the forms. So if you got questions, please feel free to email me, and good luck.